Good afternoon, everybody, and thank you for this opportunity to be with you today. Before I get started on the talk, I need to say why you ought to believe what I have to say. Like many of you, I have a PhD in rock fracture mechanics. That was a test. But after doing my PhD, I came to Cornell 37 years ago, and during that period of time, for decades, I was a consultant to and a researcher for the oil and gas industry. So I worked very closely with the people there, so I can assure you I know what I'm talking about, but you'll be the judge of that. The topic is leaking wells. You all have a notion of what an oil or gas well is, but you probably don't know what it means to have a well that's leaking. So, and I have to warn you, there's going to be a lot of graphs and charts and equations, so calculus experts, anybody? This is going to be deep, stay with me. But I'll try to translate things so that everybody understands. So if you were standing at a wellhead where the well comes out of the ground, you would see this steel pipe called a casing, and the gas or oil is supposed to come up out of that steel pipe. That's the idea of the well. You drill down, you drill out, and the stuff that's down there comes up, goes into a pipeline, goes to your homes, heats your house. Well, sometimes things go wrong, and the wells leak. So this is what a leaking well looks like. It sort of looks like a hot tub. What you're seeing here are bubbles, in this case of methane gas, and they're obviously coming up outside the well. So the well is leaking. Well, so what? Well, a leaking well, as you can see, can emit natural gas, also known as methane, directly into the atmosphere, as this well is doing. And as you probably know, or you should know, you're required to know, methane is a very potent greenhouse gas, about 86 times more potent than carbon dioxide pound for pound. In addition, it's also possible that that leaking well can contaminate underground sources of drinking water. And you probably know that many people who live in upstate New York are not on so-called city water, they're on private water wells. And if their water wells are nearby a well like that that's leaking, there is the possibility that that leakage can contaminate their water well. So this is an important question. How often do wells leak? Because if we don't know that, we won't be able to predict what might happen in New York State if New York State eventually decides to allow the development of shale gas and shale oil on the order of, as you heard this morning, 30 to 90,000 wells. We'd like to know what would be the impact of that on underground sources of drinking water to the majority of people upstate who live and drink on private water wells. So how common are such failures? To answer that question, we got to know, well, how frequently are wells going to be drilled? And then how frequently will a drilled well fail? Make sense? So we'll try to answer those questions. First, you have to understand that shale gas development or shale oil development is very different from what's called conventional oil and gas development. And the most fundamental difference is that you need one hell of a lot of wells. Pardon my French. Typically 8 to 10 wells per square mile. And what that translates into in this cartoon provided by one of the gas companies is, here's your upstate New York agricultural region, and this is a pad, an area where wells are going to be drilled. Here's another one, another one, another one. The pads appear in what are called patterned, clustered arrangements. And on each of those pads, there can be many wells, 6, 8, 10 wells. So what you see here is from each of these pads, there are 6 wells. And the whole idea is to literally bludgeon the poor shale to death with as many wells as you could possibly fit. Well, that means there are going to be a lot of wells per unit area. And if wells can fail, then the probability that there will be failures goes up in direct proportion to the number of wells. So it's important that you understand that they can't develop shale gas and shale oil economically without drilling many wells per unit area. That translates into something like this. This is a map of a northeastern Pennsylvania county. It's Bradford County. This is the New York-Pennsylvania state line right here. And what you're seeing here in different colors are the lease holdings of various gas operators that are currently drilling for shale gas in that county. And what you'll notice is that a vast majority of the county is already leased, and every one of these rectangular-like areas is an area in which there are going to be 8, 10, 12 wells. And each of the black dots would be a pad where the drilling occurs. So this is a proof of the intent which would cross the line into New York, what we call spatially intense development. There will be a lot of wells. Remember, the question is, what's the probability that my water well is going to get contaminated? To answer that question, how many wells are going to be nearby my home? What's the probability that any one of those wells is going to leak? We're not there yet. All right. So you begin any good science project, as you heard earlier this afternoon from one of our talkers, speeches, by doing a literature search. So, of course, we went to the popular literature. In this case, it was a front page headline in the Columbus, Ohio Dispatch newspaper, and they declared that gas leaks from shale wells are rare. But, of course, that's not exactly peer-reviewed literature. We weren't about to take the word of a newspaper article. So we did the next best thing, and we went to the industry literature. And the industry literature is pervasive, dense, long. There are over 260,000 papers published by the Society of Petroleum Engineers over the last 100 years. None of those papers are peer-reviewed. They're reviewed by peers, but they're not peer-reviewed. Nonetheless, they come directly from industry. And as you heard from one of the talks earlier this afternoon, sometimes a paper is nothing more than a self-advertisement. So nonetheless, sometimes data or information shows up in the industry literature. And I'm going to show you a couple of charts and graphs. I'm not afraid to do that with you because we are New Yorkers, and as you heard earlier today, New York stands alone as being the most enlightened state in the community, enlightened state in the country, one of the most enlightened entities on the face of the earth that currently is saying, not yet, which means we're all above average intelligence. So here's a graph, comes directly from the industry. This is the age of a particular well, and this is the percentage of wells of a particular age that are leaking. Don't worry about the acronyms. SCF means sustained casing pressure, SCP. It means there's gas coming up outside the well like I showed you in the video. What do you notice in that graph? I already told you. Here it is. Whoop. About 5% of wells fail soon. Here's brand new wells. They're less than a year old. 5% of them are already leaking. You also notice that as wells age, the rate at which they leak goes up, so that by the time they're mature, 15, 20 years, about half of them are leaking. Well, that's not rare. But industry would say that's offshore wells. It has nothing to do with what happens in Pennsylvania or what might happen in New York. So we go farther into the literature. We go to another paper, more recent. And in this paper, some researchers in Canada looked at over 340,000 oil and gas wells in Western Canada. By the way, how many oil and gas wells are in North America? Anybody know? Since the 1870s, how many oil and gas wells have been drilled in North America? Take a guess. Million? About 5 million. Okay, so there's a lot of data out there that could be had if it was transparently available, but we only get glimpses, and we take advantage of the glimpses we get. So I'm not going to ask you to absorb what's in these bar charts. I'll just summarize it by saying in this particular paper, they determined that the percentage of wells that were leaking by way of sustained casing vent flow, it's the same thing you saw in that video, or as measured by what's called gas migration. In other words, a well can be leaking, but you wouldn't see the evidence of the leaking at the wellhead. You'd walk out in the field, look at the wellhead, and you'd swear it wasn't leaking. You put a sniffer on it that can detect methane, no methane. You go a mile away, and the gas is migrating up in a farm field, or in a creek, or in a pond. So mere evidence at the surface of the well that you're not seeing leaking doesn't mean the well isn't leaking. These people were smart enough to know that. And what they found is that if the wells were conventional, the yellow wells, the wells that just go straight down, leakage rate was somewhere around 15, 16%. But if they looked at modern deviated wells, the industry has interesting words to describe its things. You know, a well is deviant never mind. Deviated means not going straight down, and all shale wells are deviant or deviated. They have to go down and out. And what they determined is that of all the wells they looked at that were deviated, somewhere around 65% of them were leaking. Okay, more industry data. By the way, industry continuously sponsors conferences and workshops on leaking wells while proclaiming to the public and especially to regulators that very few wells leak, which I find ironic. So I attended a webinar earlier this year given by, yes, the Society of Petroleum Engineers, that's SPE, and one of the slides in that talk was of the 1.8 million wells that the company that this guy happens to work for knew about, 35% of them were leaking. Evidence is mounting. But once again, we go back to the literature. Here's some more data directly from a website for a consulting firm run by this fellow who writes papers that says wells don't leak, but then runs a consulting firm to help people fix wells that leak. And in order to get business, he has to tell people that a lot of wells leak. So here's his data. And once you see the same pattern again, young wells, somewhere around 5%, and as the wells age, the leak rate goes up, and once again, you see these numbers up in the 30-35% range. So I've given talks with that data many times, and I get responses typically that are, Professor Ingraffea, go back to the Ivy League. You don't know what you're talking about. Modern shale gas wells is where it's at. Modern shale oil wells are where it's at, and they don't leak. Okay. Well, I didn't believe that, so we just started to do our own science. And we decided to go to where the rubber meets the road, Pennsylvania. You know where that is? You know that there are something like 7,000 shale gas wells in Pennsylvania, drilled since 2007. And we decided to do an in-depth statistical analysis of all the public data available on those wells to determine how many of them are leaking. Seems like a reasonable question to ask. One couldn't then project that if a lot of wells are leaking in Pennsylvania, we wouldn't expect many wells to leak in New York, right? Same companies, there's just a line, there's Pennsylvania, there's New York, same Marcellus shale formations, so we use Pennsylvania as a predictor of what we might see in New York. So I'm going to briefly describe what we found, and this is the first public event at which I'm going to show you some results, which tomorrow we're submitting to a peer-reviewed journal. So we went to the Pennsylvania Department of Environmental Protection's website, where by regulation, companies have to report information about their wells. It's hiding in plain sight. It's a tremendous amount of effort to go in and dig up that information, but we did. And we personally read 75,000 inspection reports corresponding to over 41,000 oil and gas wells drilled in Pennsylvania from January of 2000 up until the end of December 2012. Shale wells and non-shale wells, conventional, non-conventional. And we read all those reports looking for evidence of leaking wells. And that meant we had to do a data mining exercise using fairly sophisticated software. And then we statistically analyzed the results, not only to determine a reasonable estimate of how many wells are currently leaking, but a rational prediction of how many additional wells will be leaking. Because all the data I showed you says the same thing over and over again. As wells age, the probability of their leaking goes up. Now, you're all under 39 in this room, so you're not experiencing what I'm experiencing, but age-related degradation is common in most structures. So we use something fancy called the Cox proportional hazard model. You don't need to know about it. What you need to know is what I'm about to show you in these next couple of slides. But I have to explain to you what you're looking at. So the horizontal axis we call it analysis time, and it's measured in weeks. And it's the period of time that any one well has existed. Okay? So think of it as age of the well, but it's really the collective ages of all the wells in a certain stratum. And since we had over 41,000 wells to work with, we could stratify the wells as, well, were they conventional or were they shale wells? Were they older, say before 2009, or were they ultra-modern, say after 2009? Were they in central Pennsylvania, southwestern Pennsylvania, or close to New York in northeastern Pennsylvania? So we could parse all this statistics and do individual characterizations of how wells in each of those categories have performed and would perform in the future. So that's the horizontal axis. Think of it as a time measure. The vertical axis is the fractional probability of loss of something fancy, zonal isolation. That's the industry terminology for saying the well has failed to isolate gases and liquids that are down here from the surface or from an underground source of drinking water. It's a fancy term for leaking well. Industry doesn't like to use that word, leaking. They want that to show up in headlines. So they use something fancy that most people don't understand, zonal isolation. Is that good or bad? If you don't have it, it's bad. So think of this as the probability of failure. Okay. So we looked at all the data statewide first of so-called older wells, wells that were drilled before 2009. Now that's not exactly old, but it's not the newest wells. And we looked at two different strata. The conventional wells, that's the non-shale wells, and as you can see, somewhere around 2% of those were leaking. Then we got to the shale wells, and we noticed that as the wells age, we get up to something like 13% leaking. That's not rare. It's significant, and I'll give you a manner of measuring that significance in a few minutes. So that's one way of looking at the data. Another way of looking at the data is, well, let's look at the more modern wells, those that have been drilled in the last 3 years. And again, conventional wells start off being safer, less leaky, but as the modern conventional wells age, their failure rate goes up. Why would more modern conventional wells be failing at a faster rate than less modern conventional wells? Anybody want to offer a hypothesis? They make them crappy, and they're no longer inspecting the older wells. So if you don't inspect the well, you can't determine whether it's leaking or not. Lots of games that can be played. Then we look at the shale wells, and again, these are the modern shale wells, the ones that were drilled after Pennsylvania twice modified its regulations to once again be the state that has the toughest regulations in the world. And what we find is that the rate of failure goes up from about 12 to about 13%. And then we notice some other interesting things in the data. Northeastern Pennsylvania has seen the most active drilling. Southwestern Pennsylvania, the next most active. Central Pennsylvania, not much yet, although Pennsylvania expects to see about 100,000 shale gas wells over the next 20 years. So let's go look to Northeast, the 5 counties that are right below the New York-Pennsylvania border in the northeastern corner of Pennsylvania. And the wells that were drilled before 2009, which are now getting out close to 400 weeks old, are failing at a rate of about 5 out of 10, 1/2. And industry says, yeah, but we're constantly improving the technology. Well, that's not true by the data, because if we look at the more modern wells, for any length of time that a modern well has been in the ground compared to a less modern well, the failure rate is higher. So I told you this is going to be dense, lots of data, lots of information. And as John said this morning, most messages about environmental issues wind up being depressing, make you want to jump off a bridge at the end of the day. But we'll come to that. So what are the observations and implications? First of all, what we just shown from this recent review of the most recent data in a state where there's active development of the most modern wells using the toughest available regulations, cement failure, which causes leakage, is ubiquitous. Happens in Canada, happens in Pennsylvania, happens offshore. It's chronic. Industry has known it since 1913 when the first well was drilled, cased in cement. We analyzed very modern well technology and found that the failure rates are about the same as they've always been. And we now have increasing support for the hypothesis that the reason why hundreds of families in Pennsylvania have lost access to their water wells, as confirmed by the Pennsylvania Department of Environmental Protection, hundreds of families have lost their water wells. So far, there are only 6,800 wells. If they expect 100,000 wells, and you believe this data, how many families are going to lose access to their water wells? Tens of thousands. Okay. And how many more wells are going to be drilled every year? 25 to 30,000, says the industry. The vast majority of those in shale. So what we should expect, based on statistical analysis of past performance and reasonable prediction into the future, is that many more water well contamination incidents are likely to occur, and there's going to be a lot more methane emitted from leaking wells. Well, here's the bridge we can jump off. What are you all going to do about that? What's the obvious thing to do? What is the only reasonable way, given what's happening in Washington and Albany, what is the only reasonable way to get oil and gas operators to reduce the rate at which they're producing fossil fuels? Decrease the demand. So what can all of you do? Decrease your demand for fossil fuels. If you don't like what I just showed you, if you don't want what I just showed you is happening in Pennsylvania to come to New York, then reduce your use of fossil fuels and let the people in New York who are running the show, let them know that you don't need the fossil fuels. You can get by with something else. So thank you very much for your attention this afternoon.